Good morning. I am Devasena. In this lecture, we are going to discuss about partial pressure of oxygen measurement in blood (PO2). This topic is present in the subject Medical Electronics. Pressure of oxygen in blood (PO2). This measures the pressure of oxygen dissolved in the blood and how well oxygen is able to move from the airspace of the lungs into the blood. The term PO2 is defined as the partial pressure of oxygen respectively. The partial pressure of gas is proportional to the quantity of that gas present in the blood. PO2 measurement. The partial pressure of oxygen, that is PO2, in the blood is measured directly by the electrode. The normal acceptable range is roughly between 85 and 100. An increased partial pressure of oxygen is usually the result of excessive oxygen administration that needs to be adjusted downwards on such results. A decreased PO2 is often the result of any number of respiratory or cardiopulmonary problems. Let us see the gas exchange takes place in alveoli. Here is a representation of the gas exchange that takes place in the alveoli. Normally, pulmonary artery carries the impure blood. In the impure blood, carbon dioxide is present. This pulmonary artery carries the impure blood and the impure blood is passed to the lungs. In the lungs, it is passed to the alveoli. Now, in the lungs, already a rich amount of oxygen is present in the alveoli. Now, in the alveoli, gas exchange takes place. That is, carbon dioxide that is present in the impure blood is transferred to the alveoli, and the oxygen that is present in the alveoli is transferred to the blood. Now, the blood gets purified. The pure blood is carried by the pulmonary vein. Now this pulmonary vein pours the pure blood to the left atrium, and from it is being passed to the left ventricle and it is being distributed to other parts of the body through the arteries. Gas exchange in body tissues. Here we are going to see how the gas exchange takes place in body tissues. Blood is carried from the heart. It comprises of rich amount of oxygen. That blood is passed to the body tissue cell. In the body tissue cell, carbon dioxide is present. Carbon dioxide from the tissue and oxygen that is present. Now, in the blood, the carbon dioxide is placed. If the carbon dioxide present in the blood means the blood gets impure. So, the impure blood is now returning to the heart. This is indicated in the diagram. Let us discuss about the internal respiration. Internal respiration is the diffusion of oxygen from the systemic capillaries into tissues and carbon dioxide from tissue fluid into systemic capillaries. Oxyhemoglobin gives up oxygen which diffuses out of the blood and into the tissues because the partial pressure of oxygen of the tissues fluid is lower than that of the blood. Here is the representation. The cross-sectional view of the respiratory membrane is shown below. In this respiratory membrane, the area between an alveolus and a pulmonary capillary where the oxygen and the carbon dioxide diffuse across easily is indicated in this diagram. PO2 electrode, that is Clark electrode, we are going to discuss now. The platinum wire, which is an active electrode, is embedded in glass for insulation and only its tip is exposed. It is kept in the electrolyte solution in which the oxygen is allowed to diffuse. Here is a representation of the Clark electrode. This circuit comprises of platinum cathode and Ag anode band. The reference band is AgCl. We have electrolyte jacket and polypropylene membrane. This is indicated in this diagram. Clark electrode representation is shown here. The reference electrode is made up of silver chloride AgCl. A voltage of 0.7 volt is applied between the platinum wire and the reference electrode. The negative terminal is connected to the active electrode through a microammeter and the positive terminal is given to the reference electrode. Periodic or routine cleaning of the tip with pumice is required because polypropylene attracts protein. The partial pressure of oxygen electrode contains a platinum cathode and silver anode. The electrode is polarized by applying a slightly negative voltage of approximately 630 millivolts. The tip is protected by a polypropylene membrane that allows oxygen molecules to diffuse but prevents contamination of the platinum wire. Oxygen migrates to the cathode is reduced, picking up free electrons that have come from the anode through a phosphate potassium chloride electrolyte. Changes in the current flowing between the anode and the cathode result from the amount of oxygen reduced in the electrolyte and are proportional to the partial pressure of oxygen. The partial pressure of oxygen electrode basically consists of two terminals. The cathode, which usually made of platinum, that is negatively charged, and the anode, which usually made of silver chloride, generally it is positively charged. The electricity source, that is battery or wall electricity, supplies the platinum cathode with energy, that is the voltage of 700 millivolts. PO2 electrode apparatus is shown here. This is the circuit that is used for measuring the partial pressure of oxygen. This voltage attracts oxygen molecules to the cathode surface where they react with water. This reaction consumes 4 electrons for every oxygen molecule reacts with water and produces hydroxyl ions. The consumed 4 electrons in turn are replaced rapidly in the electrolyte solution as silver and chloride react at the anode. This continuous reaction leads to continuous flow of electrons from the anode to cathode, that is electrical current. This electrical current is measured by using an ammeter, electrical current flow meter. The current generated is in direct proportion to the amount of dissolved oxygen in the blood sample. Due to the negative terminal, the oxygen reduction takes place at the platinum cathode. Finally, the oxidation reduction current proportional to the partial pressure of oxygen diffused into electrolyte can be measured in the microammeter. The electrolyte is generally scaled in the electrode chamber by means of a membrane through which the oxygen can diffuse from the blood or sample solution. Disadvantages of PO2 measurement. The reduction process in the platinum cathode removes a finite amount of oxygen from the cathode. There is a general reduction of current with respect to time.
Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video means kindly share this video to your friends. Thank you.